We are doing scientific notation and actually doing operations with that. And simplifying that, we're just going to multiply and divide by the scientific notation. And here is, after my, again, thousands of years of doing this, okay, here is the first thing I want you to remember. After all the smoke clears, when you are done with the problem, it must be in scientific notation. That is the part where people probably go wrong with that. And I suppose because there are 28 of you all at different mathematical levels and or abilities, let's review quickly. What is scientific notation? When is something in scientific notation? There have to be, I guess, 3 different things to make it in scientific notation. The first one being what, Kyle?
Make number between 1.
Okay, the number has to be between 1 and 10. And it can't be 10. Okay, that's point number 1. Number 2, you have to have the times 10 thing. And number 3, there has to be an exponent of 10. Those 3 things have to be in scientific, to make it in scientific notation. I'll give you a second right there, because I need a new screen. And you don't want to miss out on the examples of this, because the examples will lead you home, and you will be free. You will be free indeed. What is today?
18.
What number Wednesday is this? How many Wednesdays have we had?
Three.
This is the 4th one or the
Three.
3rd?
Three, because next week is the 4th. It's the third.
What was the date of the first Wednesday?
Today's the
Well, let's work with that. Today's what?
It's 18.
So there was an 18th, there was a
11.
11.
There was 4.
and there was a 4.
4 was the first.
Perfect, that means I don't have detention.
Yay!
Okay, ready? Here's example. You didn't get that, well, right faster. 1.2 times 10 to the 5th times, that orange is not easy to see, 3.0 times 10 to the 5th. 3.0 times 10 to the 5th. I will try to walk you through this as easy as humanly possible. It's almost logical. The very simple steps of this are step number 1, multiply the left side. In other words, these 2 left numbers, step number 1, you're going to multiply 3 times 1.2, and you will get 3.6. Take your word for it. Step number 2, again, just like always, you're going to write down times 10. But we're going to keep it in scientific notation. Now, 3 is where people get confused. Okay? Because in number 3, we're going to multiply the right sides. Okay, in other words, I'm going to, for step 3, I'm going to multiply 10 to the 5th times 10 to the 5th. Okay, now if you remember, here's a little review of putting things together here. If you have 5 tens times themselves, and then you have another 5 tens times themselves, you don't end up with 25 tens, which is what you think when you say 5 and 5. You only have 10 to the 10th. When you multiply bases that have the same exponents together, you add those exponents. You don't multiply them. You have 5 tens and another 5 tens, that's a total of 10 tens. This, and then you look at this and make sure, is this in scientific notation? It is, but sometimes when you multiply those left numbers together, you'll get something that isn't between 1 and 10, and then you have to change it, which is what we're going to talk about right now. Example number 2. Number 2 looks like this. Let's change the colors. It's a simple thing to do, but a lot of people get it wrong because they just don't think a whole lot. 4.0 times 10 to the 4th. 4.0 times 10 to the 4th multiplied by 5.0 times 10 to the 5th. Okay, following the rules, you'll see where we run into trouble here. Left side, 4 times 5 is actually 20, or 20.0 if you want, times 10. And the only thing you have to remember is you're always going to add these exponents together. So 4 and 5 adds together to give you a 9. That's close to my answer, but it's not right because I can't have a 20 in scientific notation. It has to be between 1 and 10. But the fix is very easy. When you run into this, you simply need to move the decimal so that it does make it between 1 and 10. So I do get 2.0, but obviously something else is going to have to change, and that is the exponent of 10. Okay? And here's what you got to tell yourself, this. Okay? If, I suppose we should write this down. If you make the number bigger, the exponent gets smaller. They kind of balance each other out. And vice versa. Which means the opposite is true as well. If you make the number bigger or smaller, the exponent gets bigger. So, you just need to think about this. I went from 20 down to 2. I moved this decimal 1 place and made it 1 place smaller. So I need to make this exponent 1 place bigger. So it actually becomes 10 to the 10th power. Okay. If this number becomes smaller, this number becomes bigger. If by some reason you had to make this number bigger, that exponent becomes smaller. Just the way it works. Write it in your notes so when you see it, it happens there. How?
So if you have like 200, then would you add minus 2?
If you had 200 times 10 to the 8th power, you would have to take the decimal that's right here, make this 2 smaller. You still get 2.0. If you made this 2 smaller, you have to make this 2 bigger. And the other way around, if by some chance you end up with 0.04 times 10 to the 9th power, if I move this 2 places this way and make this 2 bigger, I have to make that 2 smaller. Now you have to be careful with that because you can also be working with decimal exponent or negative exponents. If I had 0.04 times 10 to the negative 6th power, and I moved that decimal 2 places and made it 4 times 10, if I made this 2 bigger, I make this 2 smaller. What is a negative 6 minus 2? It's a negative 8. And that's why if you look at your little rules, if I add a negative 6 and a negative 2 together based on the little sheet I gave you, you get a bigger negative. You're going more negative. And that's what happened. Yay. Kendall.
When they're like little parentheses, why don't you multiply the
Lost ways, what are you asking me?
like the 10 to the power and 10 to the power? Why don't you multiply the 10?
I did.
Well, but then it would be 100.
Huh?
But then it would
But
be
that's what
100.
I'm doing when I'm doing the exponents. Kendall, if you really, really, really want to, do you know what 10 to the 5th power is? It's 1 with 5 zeros after it. Feel free to take 1 with 5 zeros after it and multiply it by 1 with 5 zeros after it. You're going to get 1 with how many zeros after it? 10. which is the same thing as 10 to the what power? That's what you're doing when you add those exponents, you are multiplying those 10s together. It's just the way it works. Another example that, Kendall, maybe this would help you. If I take 2 to the second power and multiply it by 2 to the third power, okay, I don't get 4 to the fifth power. I don't change these numbers. I have 2 times 2 times 2 times 2 times 2. I have 5 2s, not 5 4s, which is what you would say in your Now, we haven't got to the more fun and exciting thing of division. But division really is no different. It's going to be basically the same thing. Let's do this one. 3.0 times 10 to the 8th power, 4 times 10 to the 4th. Okay. Same exact rules apply. Step number 1 is do the left side. Does anybody know what decimal I get when I do 3 divided by 4? Okay, let's do it. 4 into 3, you get decimal point 7, 28, 20, you get 0.75. You write down your point, or you write down your times 10. Now maybe you can make this logical jump on yourself. If when I multiplied bases that had exponents together, I added them together, now I am dividing bases that have exponents. What happens, Emma Kunacek? You subtract them. So 4 from 8, and you're subtracting the bottom. Be careful with this. It's 8 minus 4, which is to the 4th power. And I'll show you why, because what does 10 to the 8th power mean? I have 8 10s times themselves. And that's all over 4 10s times themselves. Well, cross off 1 for 1. Really all you end up doing is subtracting the bottom from the top, and you end up with your 4 10s on top. Now again, my problem's not right. Why, Charlie?
It needs to be a negative.
Ooh,
Like if you're
no, 8 minus 4 is not negative.
Oh, there is a 2 4 minus 8.
Oh, okay.
No, 8 minus the bottom. Top minus the bottom. Okay, non-scientific notation, because why, Bailey Lankin?
I don't know.
Why is this non-scientific notation, Eva? Why, Rich?
Because it's between the number 1 and 10.
Right, this number is not between 1 and 10, you just need to move the decimal 1 place, then it becomes 7.5. I made this 1 bigger, this has to become 1 smaller. Okay, and again, this is not hard stuff, but it's very confusing if you don't look at your notes and go back and say, oh, what did we do then? I mean, it's all addition and subtraction and division and multiplication, but it's like, you have to keep it all straight when you do what at what time and what happens here. Here's one for you to try, and I'm sure you'll be incredibly ecstatic about it. 7.5 times 10 to the 8th power. I can't even tell if those are 8s or 6s. 7.5 times 10 to the 8th power, all divided by, what is it? 2.5 times 10 to the 6th. I'll give you 30 seconds or less. You should be done. Wait, I can see my color. Really? All this time I could have done this? Will it show up over here or no? Oh yeah. Where does it say undercover?
Over on the underneath the rainbow.
It never shows up over here still. Alright, if you divide it out 7.5 and 2.5, you end up with Ashley. If you subtract the bottom from the top, it's 10 to the. Now, open your books please to page 315.